So as you know, my name is Jakub, and I will introduce the paper presented by my co-authors with the earlier paper, and they want to present a novel iterative approach to determining compromise rankings. And yeah, in this paper, my colleagues propose a new method for determining compromise rankings based on reference evaluations, and they use 3 selected MCDA methods to achieve that, namely TOPSIS, VCOR, and SPOTIS methods. And okay, so to move on, the main contribution of the work is the concept of a new approach to verifying compromise solution. As you may know or may not, there exist plenty of methods which can be used to achieve that, but the proposed solution is quite new, so it should be verified multiple times, and to be sure that this approach could be used in the real life scenario. And due to existing a lot of MCDA methods, and it is common that multiple MCDA methods are used within the one problem. They provide different rankings. So yeah, it should be borne in mind that those methods and their differences should be taken into the one ranking and to provide the best possibilities of decision alternatives. And the concept of the compromise solution is to use the iteration to determine the subsequent rankings. And something about the used methods. TOPSIS stands for Technique of Order Preference Similarity, and it is one of the most popular methods from the group of MCDA methods, and it uses the closeness to ideal solution. Main steps can be determined as follows. We can distinguish 5 steps, and as I said, the main step is to calculate the positive and the negative ideal solution. Moreover, at the beginning, the decision matrix is normalized, and using the determined grades of criteria, the weighted normalized decision matrix is calculated. At the end, each alternative score is calculated. And about the VCOR method, it was developed by a Serbian researcher, and it is also one of the most popular methods in the MCDA field. And the main distinguishing feature of this method is that it provides 3 rankings, namely S, R, and Q, and those rankings, those values can be used to determine final ranking order. And about the last method, it is a SPOTIS. It's stable preference ordering towards ideal solution, and its main advantage is that it's completely free to rank reversal phenomenon, and it uses the ideal solution point in calculations to provide the preference of alternatives. About the SPOTIS method, also we can see that those 2 formula are the core of this method, where we use the distance to ideal solution, and then we multiply it by weights determined in the problem. To check the results similarity, as in the previous paper, we used my colleagues used weighted Spearman correlation coefficient and WS ranking similarity coefficient. 3 main steps of the proposed methodology can be distinguished. First one is to evaluate the formed decision matrix by an MCDA method. Second step is to create a decision matrix based on the ratings of the MCDA methods, and criteria types are determined based on the method ranking type. Last step is the return to step 1 until the ranking I minus 1, and the ranking of I is the same. Yeah, decision matrix used in the problem was also randomly generated, and it consists 4 criteria and 10 alternatives. The authors used the same weights. So in this case, when we have 4 criteria, each weight equals 0.25, and the first 2 criteria was profit type at the beginning, and the last 2 criteria are cost type. Here is presented the beginning initial decision matrix, and as you can see, the data vary between 0 and 1, and there is presented a visualization of subsequent rankings obtained by different methods. As I mentioned, TOPSIS, VCOR, and SPOTIS were used in the study. So we can see that 5 iterations of compromise ranking searching was performed, and we can see the differences between subsequent steps of rankings. And here we can see that correlation coefficient, namely Spearman weighted coefficient, was used to assess the ranking similarity in subsequent steps of iterations, and we can see that the VCOR method was the last to achieve the perfectly same rankings. However, the TOPSIS method achieved the same ranking in the 3rd iteration, and the SPOTIS achieved it in 4th. And here we can see the WS similarity coefficient applied in results comparison. So the results are quite similar to the results presented in the previous table. However, the indicated similarity differ quite. So yeah. Here we can see the visualization of the rankings when we compare the last iteration to 1st iteration with subsequent methods and TOPSIS, VCOR, and SPOTIS, and we can see that in fact the VCOR method provides the most diverse results when we compare it with another method. So yeah, it demands the most iterations between to achieve the compromise solution from the beginning ranking. And the conclusions from the research, it allows the proposed methodology allows for flexible usage and guarantees the reliability of the results as shown by tests performed. We can show that by the 5th iteration, the results are the same between those methods. So it's not time demanding, and I think it's worth to test this approach in the multi-criteria field. And yeah, the WS similarity coefficient shows that the results at the beginning are highly similar, and at the end of the iterations they are strictly the same. And for future works, it should be performed that compromise solution for bigger dimensionality of the problem should be addressed, and moreover, the different weights allocation between criteria should be also tested to check if it impacts the final outcome, and moreover, because of the fact that we have plenty of MCDA methods available, maybe more of them should be engaged to perform such an evaluation to check if the compromise solution would be achieved as quickly as in this study case. Thank you for your attention. I think that's all about this presentation. If you have any questions, please feel free.
Thank you so much, Jakub. Do we have any questions from the audience? Oh, I just have a quick comment that this paper actually I enjoy very much because in the multi-criteria decision-making, when they have so many rankings, right, especially connected with the previous question, what's going to happen when we have maybe hundreds of different criteria? How can we measure our ranking having so many different rankings from so many different criteria, right? So connecting this to the work I've been doing in multi-activity optimization is how can we calculate some average of ranks or meta rank, especially when objectives can be so conflicting with each other, right? It's very important. I'm happy to read later the full paper to see how are the internals of this. So if I can apply this to other my machine learning algorithms. So thank you so much, Jakub, for the presentation.
Thanks a lot.